Well, welcome everyone. Today I'm going to be talking about Microsoft's Azure Verified Modules from my perspective as a contributor. I've been contributing to this initiative for quite a few months now, almost since it became public. So I'm going to start with a little bit of background, and if anyone out there has got a QR reader to hand and you want to scan the poll on the right-hand side, that would be quite cool. It would just give me an indication of who's on the call and what your experience is with AVM to date. So it's an initiative led by Microsoft, and its goal is to set the standards for what a good quality infrastructure as code modules look like. It's run by Microsoft for the whole community, for customers, for partners, and also for internal Microsoft initiatives. And the idea is to devolve the ownership to product groups, so that the actual people who sort of are responsible for the Azure resources and are sort of able to support the AVM modules and leverage both internal Microsoft and external communities. The initial target for AVM is application teams, meaning workloads rather than platform teams. And the aim is to standardize how resources and architecture patterns are created. So I guess we know what Azure means and we know what a module is, but what does verified mean? So that's what this slide is about. The key thing, and I think this is one of the most important things, is it's supported by Microsoft, and they've got a support statement, which I've linked on that top line there. There is also a specification that underpins AVM, which is designed to drive consistency between resources. Microsoft have committed to keep these resources up to date with product and service roadmaps, and to that aim, every single AVM is led and managed by a full-time employee as the community, we can contribute to AVM modules as co-owners, but the ownership of the module itself is with Microsoft. AVM modules are by default aligned to WAF recommendations, so encourage alignment to the resiliency, performance, and security tiers. They include documentation along with examples, and the examples actually have dual purpose. The examples within AVM are actually ran as tests. So the ones that you see within the modules provided as examples are actually deployed as part of the workflow of making sure that these resources operate. AVM resources are broken down into both resources and patterns, and you can think of resources as a wrapper around an Azure resource with a consistent design and a consistent scoping. They're designed to be composable, so they're designed to be Lego bricks. Yeah, so from the perspective of adoption, it means that you don't have to take on board the entire AVM initiative to start using these. You can use individual modules that make sense and then gradually adopt. As I mentioned already, the default settings are designed to be WAF aligned, so without changing parameters, you will have a resilient resource. And as an example, if you are deploying AVM resources, say in a lab setting, you may need to consider the cost side of things, because obviously you can't have both performance and resilience as well as cost. So in that scenario, say for instance, you were working in a lab, you'd need to set explicit parameters to make sure that you used a lower cost SKU, or you didn't use zone redundancy. Above the resource modules, which are available for both Bicep and Terraform, there is the concept of patterns, and these are designed to combine resources together in sort of mechanisms that make sense. As an example, I've got an open source function app with secured storage pattern, or it's possibly a mechanism to introduce simpler abstractions to make it easier to consume the resources in specific scenarios. At the moment, all resources are labeled version 0 dot something, but they are production ready and supported. Microsoft are actively seeking feedback. The reason why they're currently not at 1 is because in order to get to that point, we'd like to understand their use in the broader community and across more customers, and then use that to stabilize the interface before it reaches 1. They are absolutely ready for use. So where did AVM come from? So it's actually a combination of a number of initiatives. The two key ones are the resource modules, the Bicep resource modules, also known as Carmel, which has been around for quite a while, and a smaller initiative called Terraform Verified Modules. Both of those have basically been superseded and folded into the Azure Verified Modules. So the Azure Verified Modules is now the umbrella mechanism for those previous resources, and you can see the difference in the heritage between the two in the table on the right hand side. That Bicep, the Carmel library has got a lot more coverage, and so there's a lot more resources currently available in AVM for Bicep. Terraform is catching up, and there's a great opportunity for people to get involved and to help build these Terraform resources. As you can see, there's a big gap between available and proposed, and so there's an amazing opportunity to get involved. Overall, Microsoft's mission, as described there, is to make this module library a sort of comprehensive resource for both Bicep and Terraform, and potentially other languages in the future, following the well-architected framework. And it will become the trusted Microsoft source of truth for IAC modules. And one of the interesting aspects of the module, so besides the code itself, the actual design of AVM is open. So the thought processes, the governance that goes into AVM is available on the web page. So there is a shared specification which tries to drive commonality between Bicep and Terraform where it makes sense. And there's specific specifications for Bicep and Terraform as well. And that's particularly interesting because it means that you're able to see the thought processes that go into why modules are made a particular way, and some of the design thinking behind them. So feeding all that together, why do I think what makes AVM special? What makes it special compared to what's been done in the past? To me, it's the combination of the things on the screen. It's the commitment and strong technical leadership from Microsoft, the design, the open book design approach, and the engagement with the community, which I think is key. Those three things together, I think make AVM a very exciting initiative, because collectively we can pull our experience not simply at the point of or at the perspective of code, but also the perspective of design, and sort of use this collective experience to build a common definition of good. Fundamentally, by sharing this experience and building these resources together, I feel that means that we can focus more on the application workloads and therefore the business outcomes, knowing that we've got this solid foundation to build upon. So how do you get started? There's a list of available modules on the AVM webpage. There's the link at the top. And there's a couple lab resources, which are very useful to help you get going, depending if you want to take the Bicep track or the Terraform track. In terms of how it actually works, we'll have a look in a minute in Visual Studio Code. But as you see, it's basically you can reference the module via a source flag, and it is obviously recommended to make sure that you pin the module to a specific version, so you always know you're going to get the same information each time. One more thing of interest before we have a look at the module itself is the idea of shared interfaces within the module. And the idea here is this is partly to drive this consistency between resources. So the example is a Key Vault resource, and the shared interfaces are common to many Azure resources, so private endpoints, resource locks, and so forth. The idea of this specification is that when you know how to add a private endpoint onto a Key Vault, it's the same mechanism that you use to add a private endpoint onto a storage account and so forth. And same with other resources such as the role assignments. So with that in mind, I'm just going to switch over to some code and just illustrate what these shared interfaces look like. So I'll just make this slightly larger. So on the left-hand side, we've got some Bicep, and on the right-hand side, some Terraform. And the reason for showing these side by side like this is just to give an indication of that alignment that I was talking about previously, and also to show how these various resources are combined and grouped underneath the resource. So Bicep on the left, obviously, you can see the keys, and a bit further down, there's some secrets down here too. Design pattern with verified modules is that the resource covers both the parent resource itself, so the Key Vault in this case, and its children, which in the case of Key Vaults would be secrets, certificates, and keys. So you see them as child objects as here, and you see the same pattern on the right-hand side with Terraform. And you can see when I hover over, you get rich IntelliSense from the module. That's because the module itself, the types are very well defined, and there's a very good description underpinning it, which makes for a very good IntelliSense experience from within Visual Studio Code or your editor. Illustrating another example, private endpoints here. A very similar pattern between Bicep and Terraform, specifying this is the minimal configuration. This is both the so this basically is specifying the subnet resource, which is where the network card will be placed, and the private DNS resource ID, where the DNS record will be created. And again, very, very similar between the two. And continuing on to role assignments, repeating this, and secrets. There is a slight difference, and this does illustrate the difference between sometimes you have to do things differently within the languages. Within Bicep, there's the concept of a secured list, whereas within Terraform, it's split between secrets and secret values because of the way that the secret values are marked as sensitive. So again, there are occasional differences between the two, which are driven by the capabilities of the language. Just to illustrate the scope and flexibility, I've also created my third secret here, and that sort of shows the full use of various parameters within the secret, including the parameters which perhaps are not frequently used. And in the second secret here, I'm illustrating that the role assignments and other sub-resources such as tags are also echoed down to these child resources as well, again in that same consistent manner. So the role assignment pattern that you see there is exactly the same as the one you see there applied to the parent resource. And if you're thinking, can you do the same thing with a storage account and storage containers, you'd be absolutely right. You can use the same pattern to apply role assignments at the storage account, and then apply it down also, say, to a container, to role assignments at a container level as well. If you go look at the AVM labs that I shared in the link previously, you'll see an example of that, where the VM and the storage account is secured in that manner. I would, excuse me. There is a very active community, and there's a list of resources if you're interested to go to visit to get started. And literally just announced just recently the external community calls. So there's a dedicated page which I've just linked. And if you're interested in general about writing AVM modules or any general insights on Terraform best practices, and I'd also recommend subscribing to Matt White's YouTube channel. Matt White is the lead Terraform engineer across Azure Landing Zones and the AVM initiative. Extremely interesting. As a final piece, just before we close, what I'm going to do is I'm going to take more. So we've talked about how do you use these resources and what they look like from that perspective. We're now just going to switch over and look at what an AVM module looks like under the covers. So I just find my So this is an example of a container apps managed environment. So AVM modules have a README here, which is automatically generated. So if you've seen Terraform docs, it's basically based on that. Each resource has a number of examples. So if you remember before, I said that each of these examples is actually tested. So every single time you do a pull request against this particular repository, each of these examples is actually deployed to Azure to make sure that they are functional, as well as the static and linting checks which run against the repository to make sure that the code is as it should be. In fact, I can actually illustrate that, because I know at the moment that this particular module is not passing linting tests, so I'm gonna intentionally break it. There's a little helper inside the module called AVM, and I'll just illustrate that quickly running first. It runs as a Docker. Within a Docker container, and I'm currently using it from WSL because it's easier. And hopefully the demo gods will smile on me. So this process obviously runs as part of the PR checks. And so you can see there's an automatic process to generate the documentation. There's also an automatic process that you can check locally to lint things. And there's a global task available called PR check, which will basically runs all sorts of tests. It will run Terraform validate against each of the examples. It's just an extremely useful thing to be able to run before you do a pull request back to GitHub. So you've got a reasonably good feeling that the repository is actually going to work. So I'm expecting this to come back with some errors, and there we go, there it has. So no functional problems here, but it's basically telling me off for not using nullable, and it's saying I've got some of the types are not quite laid out exactly as they should be. So I've left this in on purpose as an illustration of the sort of checks which are happening. So that these are an evolving set of lints that go beyond the basic TF lint checks, which are specifically designed for AVM. Another thing which happens in the background, if you ever go look at an AVM repository, and I'll just grab my one of my ones over here. Yeah, actually, I will stop actually and just change tack slightly on some of these things. So there's if you want to consume modules, they are so for Terraform, they're published to the Terraform public registry, and you can find them by searching for AVM and search for the Azure organization. And as you see, so if we was to go into one particular one, let's look at Key Vault, which is the one written by Matt White. There are a number of examples available, which you can see here. And again, comprehensive documentation. That's a good way to find the resources. When it comes to writing a module, there is a template available. So this basically is a good way to get started, and you can create an AVM module by coming here and then saying create this new repository. And I actually did that earlier. I made a resource for the Postgres flexible server from that repository. And another really good tip for getting started with that, I'll see if I can share. There's an excellent little utility called NewRes, and I'm just going to illustrate what that does. So, oops, let's try that again. So what NewRes lets you do, or what it does for you, should I say, is it reads the Azure RM schema and helps write the main and variable file. So hopefully if the demo gods are smiling in a minute, it will come back and say, I've made a main and a variable file form for us. Pretty please. There we go. So really, with very limited effort, we've got a very flexible, that's a very flexible server using NewRes, and there is a little bit of tidying up required in order to fit the AVM naming guidance, but obviously this is a huge time saver when it comes to creating these modules. And just looking at the variables again, you see they've all got really well-defined types and good descriptions, automatically pulled. You can do this for any resource. You just need to look up the resource and punch it in, as you just saw me do there, and you get something like this. And I'm just going to illustrate just before I finish. You can do something similar with a database. So this child resource. Come on. It always goes slower when everyone's watching. So much simpler, the actual database resource itself, but the variables, again, very high quality object definition and description available. Yeah. So, yeah.
Well, thanks, Stu, for bringing that up. Yeah, that's really interesting because I think like with these verified modules, like for enterprises are definitely the way to go. And I think there are some sort of, you mentioned about those patterns. And they seem like as soon as you've been contributing to the projects, but it seems that as soon as you get the understanding of how those patterns are applied, I think like things become more fluid, right? Because in general, like if you look like a new devs or DevOps engineers coming, they're gonna go straight to Bicep or ARM, not necessarily knowing about those verified modules. So
Hmm.
how do you see like that sort of transition from someone that's starting to adopt the verified modules?
Um, I think I think so. The best way to approach learning and using the verified modules is through the labs. That's a really good. So understanding its use, I think, is the first thing. The modules themselves are designed to cover a number of scenarios, so they themselves are quite complex. But the first step is to use the modules and get comfortable with that. And I'd suggest the best place to start would be the labs, which I linked to earlier. Um, the benefit to starting and working with an initiative like this is that you don't have to think about the design aspects of how you're building things or the extensibility. So so that
Yeah.
consistency. Okay, how am I going to do a private endpoint and it makes sense from one resource to another? How am I going to design it so that if I need to add extra capabilities, I can without introducing breaking changes? That's, to my mind, the key value is all that design thinking that's gone into how these modules will be written.
No, that's very good. Yeah, knowing like that sort of how those dependencies work, right? Because I think like what you see in general when people don't use a templated way is that as soon as things grow and you have like modules and you have dependencies, that's where like the pain comes. Well, that's
Yes,
definitely going to solve those problems. Well,
definitely.
yeah, no,
Yes.
no, really good. I'm just checking like here for the questions, but I think like our time's up. I'd like to thank you again, Stu. Amazing presentation. And yeah, for the audience, we're going to come in a few minutes and we're going to continue with Global Azure.
Awesome.
Thanks,
Thank you for
Stu.
having me, Marcel.
Thanks.
Yeah, thank you. Okay.
Thank you. Yeah, really appreciate it.